Okay, in this video I just want to do a quick example of simplifying an expression using the natural log. So for instance, let's say that you wanted to simplify something like the natural log of the cube root of x squared plus 1 times x squared minus 1 squared over x cubed plus 5x plus 7. Okay, let's say you want to simplify this. Right. So this is a mess, but we can use our properties of natural log. So remember, the properties of natural log that we want are that if you have the natural log of a to the b, that this is equal to b times ln of a, and that if you have ln of xy, this is equal to ln x plus ln y, assuming that x and y are positive and a and b are positive. You don't run into these issues with the natural log of a negative number. Okay, so we're assuming that x is in this example, that none of the terms are going to be negative. This really should be written down, but it's often not. Okay, so let's simplify this. First thing, we have the natural log of a cube root, right? Well, how can we rewrite this so that you can apply one of these natural log facts? You want to write this expression as this inside raised to the 1/3 power. So the thing that we're trying to find is the natural log of x squared plus 1 times x squared minus 1 squared over x cubed plus 5x plus 7, all raised to the 1/3. Now this thing is being raised to the 1/3, and then you take the natural log. You're not taking the natural log of this thing and then raising that to the 1/3. Okay. So I have this form, the natural log of a to the b. So my a is going to be this, my b is 1/3, and now I can use this property that's b times ln a. So this is going to equal 1/3 times the natural log of this. Okay, now I have this. Well, I have, so now I have a quotient. I'm showing all the steps in this example. So when you have this, I have the top part, right? I have this thing divided by this thing, and I'm taking the natural log. So another property of natural log is that if you have ln of x over y, this is ln of x minus ln of y. Okay, basically it's it's related to the previous one, so let's just star these. It's related to the second one because I can write x over y as x times 1 over y, and then that will give me ln of x plus ln of 1 over y, and then that's oh, I have to okay, so there's a bit more to explain. It doesn't follow immediately from the second one. The third one doesn't immediately follow from the second one, but nevertheless this is true. Okay, and then also another one, we won't use this, but natural log of 1 is 0, right? And natural log of e to the x is just x. Okay, so now I have this quotient, the top over the bottom, so now I can use property number 3 and get that this is equal to 1/3 times ln of x squared plus 1 times x squared minus 1 squared minus ln of x cubed plus 5x plus 7. I might need to rotate this. Okay. Now this 1/3 is being multiplied by this whole thing, so I need parentheses like that. Now I have this that I want to simplify. This part, can I simplify that? Is there any property that lets me split ln of a sum? No, there isn't. This is as simplified as it gets. So this part I just leave alone. But I can work with this part. This part I can simplify using the fact that I have a product. So when I take a natural log of a product, it turns into a sum. So this is 1/3 times ln. Okay, so I have this thing, x squared plus 1, times that thing, x squared minus 1 quantity squared. So this I can split up using property number 2. Okay, this splits up as ln of x squared plus 1 plus ln of x squared minus 1 squared. And again, this is x squared minus 1 squared, and then I do the ln. Okay, that, oh, I don't need this bracket. Minus the natural log of x cubed plus 5x plus 7. Bracket like that. And finally, I have this term here, which I can simplify because I can use property 1 again, the first one. Well, I guess the second one, if I included ln of 1 equals 0. Let's just call ln of 1 equals 0 property 0. Then the second one is property 1. Now I apply property 1 again, and I get 1/3 ln of x squared plus 1 plus 2 times ln of x squared minus 1 minus ln of x cubed plus 5x plus 7. And that's as simplified as I can make it. I can't simplify ln of x squared plus 1. Okay, this part doesn't simplify. This part doesn't simplify. Well, if you wanted to, I guess if you really wanted to, you could factor x squared minus 1 as x plus 1 times x minus 1, but that doesn't really make it any simpler. So if you wanted to, you could split this up as ln x plus 1 times x minus 1, and then rewrite that as ln of x plus 1 plus ln of x minus 1. Okay, but that's not really more simplified than ln of x squared minus 1. So this is how you simplify it. And sometimes this will show up in the context of logarithmic differentiation. So this is in the section after implicit differentiation, where you want to take the derivative of this function. So a question on test or something, on homework, whatever, might ask you what's the derivative of this, and because it's so complicated, I mean, you could use the chain rule and product rule and the quotient rule a bunch of times, but it's easier to take the natural log of this and then differentiate that, and that turns out to be y prime over y, and then you can multiply both sides by y to get y prime. That only works if you're restricting your x so that you don't run into these issues with negative, the natural log of a negative number. Right? If you run into this issue with a natural log of a negative number, then you actually have to use the original method without using logarithmic differentiation. So they should specify, that when you have something like this, you're only working with x's such that the thing is never negative. Okay, that's an example I wanted to do because this does show up sometimes. And it gives, sometimes students, so where are the parts where students tend to mess up is, well, first of all, not doing the logarithmic differentiation and trying to do this, they'll spend like 30 minutes taking the derivative of this. Okay, that's not how you were supposed to do it. It's not wrong, it's just not how they wanted you to do it. And it'll take a lot faster if you use logarithmic differentiation. And then another common mistake is just not, quote unquote simplifying this. So sometimes students will split this up, not sometimes, a lot of times, students will split this up into ln of x cubed plus ln of 5x plus ln of 7. That's just completely wrong. Okay, thanks.